All right, have both of your handouts out. You did the equations handout from a couple of days ago. You were doing 2 through 20, the even. And then I gave you another handout yesterday. You did every other odd in class, and we did 2 through 20, the even on that one also. So if you would hold up both handouts so that I can see that you did the evens 2 through 20. Abby, you're the one who said we weren't supposed to laugh, and look at you, you're laughing. Like you're making fun of me just for my accent. It's like what I do to Matty. All right, but Matty can't do this one, we said, so. I'm not sure what it would sound like if she tried. I really want to hear it now. I'm very curious.
Managed to stand up and say that.
No.
She doesn't want to do it. Okay, all right. Well, anyway, let's start by looking at the equations handout, if we could. The equations handout, the one with the little chalkboard on it that says, remember to work slowly, accurately, and neatly. Hopefully you did so. And number 2, what did you get for your answer when you were solving for am? Which is my guess is what it would sound like if Maddie tried a British accent. But we better go to Kendall here. Kendall, what did you get for number 2?
M equals 6.
M does equal 6. Excellent job. Number 4, what did you get? Genesis?
17.5.
17 halves is correct, or you could say 8.5 or 8.5. Any of those would be acceptable. Number 6, what did you get, Abby?
X equals 3.
3 is correct. Number 8, what did you get for R? Brendan?
R equals 4.
4 is correct. Number 10, we've got some obnoxious looking fractions in there. What did you get on that one there? Speaking of obnoxious, just kidding. Audrey, what did you get for number 10?
I got 0.
You got 0. That is not correct. Let's go to Michael.
4.
Really close. Matty? Oh my. Anyone got something close to 4?
5 over 2.
No, it's not 5 halves. All right, let's take a look at number 10 very quickly together. We've got a 4s, positive 5, negative 3/4 s, is equal to a 3/4 s, negative 5. Now, it's tempting here to cancel the 3/4 s's, but we have to remember this one's a positive 3/4 s, this one's a negative. They don't cancel. Similarly, the 5 and the negative 5 also don't cancel, I'm afraid. Is that what you did? You cancelled the 3/4 s's and the 5s to get 0?
Well, I pulled out the negative and then...
I'm sorry?
I pulled out the negative and then...
You pulled out the what negative? You don't know what negative. I don't either. So anyway, it's a temptation though, and I think that might be why they did it, to see if they could get you to cancel stuff. But no, they're not exact matches, so we don't want to do that. I can, if I would like, combine the s's together here. And let's see, 4, if I took, let's just picture having 4 pies, because we don't call them pizzas in... maybe they do. Anyway, let's suppose you had 4 pies, and someone came through, like Brandon, and ate 3/4 of one of them. It's a small pie. Ate 3/4 of one of them. He's not a glutton. How many pies would be left, class?
1/4.
How much?
1/4.
Well, and then the 3 others, right? So we get it with 3 1/4 s plus 5. If I were to combine my terms, it's really gnarly, but you roll with it anyway. At this point, which is the little s now, class?
3/4.
The 3/4 s, and we can move it over as a negative 3/4 s, but again, you notice there's a little problem. You can't subtract 3/4 from 1/4, so we borrow, make this a 2, and we add that 4 more fourths to the 1/4 to get 5/4, and we subtract, we end up with 2 2/4 s, which we could turn into 5 2 1/2, which becomes
2.5.
or 5 halves, which was what I was hoping to get. 5 halves s. So the s is just nasty. At this point, we'd also need to move the positive 5 over as a negative 5, and we combine the negative 5s to get
Negative 10.
negative 10. At this point, if we multiply both sides by 2/5, that'll cancel the 5s and the 2s, and leave us with s is equal to, well, here we can also cancel the 10 and the 5 to get a 1 and 2, and we end up with not 4, but really close, negative 4. I think it's just the negative that Michael missed there. Now, there is another way. How many remember back to Algebra 1 where I talked about my hatred of fractions? I hate fractions and equations, right? And I said we could multiply everything by the
Divot.
LCD. I'm depressed now. The LCD, we can multiply everything by the LCD, and if we multiply everything by 4, it would knock out the fraction. How do you remember this now that I bring it up? Okay, so if I multiply 4 times 4s, class, I get
16s.
16s. And of course 4 times 5,
20.
20. Here the 4s are going to cancel. I'm left with a negative 3s. Here the 4s cancel, left with a 3s. And then of course 4 times negative 5, negative 20. At this point now, it becomes a lot easier to combine like terms. The 13s, negative 3s, class? 13s, positive 20 is equal to the 3s, negative 20. We'll kind of do a double switch here. We'll roll the 3s over as a negative 3s, class, to get 10s. And the negative 20, or 20 moves over as a negative 20 to get negative 40. And now the negative 4, I think it's a lot easier. Would you agree fractions are just obnoxious, but if you can get rid of them, makes the problem a whole lot easier, which is why I taught that to you back in Algebra 1. We're going to come back to that again, by the way, in Algebra 2, so if you're like, oh, I never learned that before, reckon you're lying. But anyway, you did learn it before, but if you happen to forget from last year, or 2 years ago, those who had geometry last year, we'll review and refresh over that. Number 12, let's go back to Audrey. What did you get for number 12?
Negative 3 halves.
Oh my. Michael, what did you get?
6.
It is 6. All right, go try some charm here, Aubrey. Audrey, whatever your name is. Audrey. And what did you get for number 14?
3.
That is correct. See, I knew third time was the charm. Number 16, Matty. Negative 3 is correct. Number 18, Kendall. 5 over 2, 5 halves, or 2.5, or 2.5. Any of those work. Number 20, what did you get for that one, Genesis? 21 is correct. All right. There were 10 of them on here. I don't think anyone got number 10 correct. Did anyone get s equals negative 4? All right. How many got 9 out of 10? You just missed 1. You just missed that one. All right. Anyone just missed 2? That one and one other. I just happened to call on both of them for you, okay? All right. Questions on any of these? Do we need to see any of them worked out besides the one we've already shown? Yes, ma'am. Number 16. Make sure when we square the binomial, you remember there's 3 steps, not 2. It's not square the first, square the last, but rather square the first, square the last. Multiply and double. So we should have gotten a 4x squared negative 20x positive 25. And on the other side, when we distribute 4x squared negative 8x positive 61. Did you have the negative 20x?
I didn't do the square first.
I wondered. Okay, so obviously the 4x squares will cancel away. I'm going to take the little x, which is the negative 20x, right? That's smaller than negative 8x. We'll move it over as a positive 20x. Bring the 61 over as a negative 61 to get 12x equals negative something. Negative 36. And then divide away the 12 to get x equals negative 3. All right, any others that we need to see worked out? Questions on any of these others? Going some questions. Going twice on questions. Accent gone. All right, that was for you, Genesis. I was like, she's not going to be able to hang in there much longer. All right, let's go back to normal voice. All right, number 2. On the next handout. All right, inequality handout. And I said that we solve an inequality exactly like we solve an equation. So all the same steps that we have over there, getting rid of parentheses, combining like terms, on each side, and then getting rid of the little x, getting x by itself. All of those things are exactly the same. There's only really one difference for an inequality that we have to remember. What is that one difference, Genesis? Well, yeah, obviously there's a greater than less than sign, but as far as what you do all those same things, except there's one little nuance. Brandon? One thing to remember. Michael?
If you divide by negative, you switch the whatever.
Good. If you end up dividing by negative, technically if you multiply a negative, but that doesn't happen very often. Mainly if you divide out a negative or change all the signs, which would have the same effect, then you have to flip the inequality symbol around. You wouldn't have to do that with an equal sign, because an equal sign, when you flip it, still looks like an equal sign, right? But a greater than becomes a less than, or a less than or equal to would become a greater than or equal to. So on number 2, what did you get for your answer? And let's pick it up with Abby.
X is greater than 2.
X is greater than 2. And how would I write X is greater than 2 in interval notation?
Parentheses 2, comma, infinity, parentheses.
Good, from 2 to infinity. So 2 comma infinity in parentheses. Number 4, Brandon.
X is greater than or equal to 3.
Good, X is greater than or equal to 3. And then in interval notation,
Bracket 3, comma, infinity, parentheses.
Good. 3 or greater than or equal to 3 means you start at 3 with a bracket, comma, infinity, always end with a parenthesis on the infinity. Again, these are unbounded intervals we're using here. Number 6, your answer. Audrey.
And less than or equal to -2.
N is less than or equal to -2. Let's take a look here. You combined the 2n and -7n to get -5n. And then we can move the -1 over to the other side as a to get. So we should have started with -5n less than or equal to 10. I think you divided away the -5 and you got -2, but since you divide by a negative, and it should have become a greater than or equal to here. So we should have had -2 to infinity, and since we have the or equal to, we'll have the bracket here on the -2. For redemption, Audrey, number 8.
X is greater than 2.
Good, x is greater than 2, or interval notation.
Parentheses 2, comma, infinity. Parentheses.
There we go, parentheses around 2, comma, infinity. Number 10, Michael.
X is less than or equal to -2.
Ooh, not -2. Maddie? You should have had x is less than or equal to -5, so negative infinity to -5, where the parentheses on the negative infinity, bracket on the -5. Let's go back to Michael for redemption, number 12.
Oh, that's an R. Okay, I thought that was 1. 1 is greater than 3. R is greater than 3.
What is not greater than 3? Something's a little, I think you might be looking at, no, that's not it either. What did you get for number 12? Kendall?
R is less than 2.
I did not get R is less than 2. Genesis?
I got R is less than 2.
I got 2 is less than R. I think maybe you're reading it backwards. I think you got the 3r squared minus 18 is greater than 3r squared negative 9r, right? You canceled the 3r squares. What I could do is I could double switch here, because I don't like having negative r's, right? And I could put this over here as a positive 9r. I didn't divide anything, so I'm going to leave the greater than and move the 18 over as a positive 18. Now I get r is greater than 2. If we didn't do that, if we just divided away the negative 9, we get positive 2, flip the inequality, less than r. But how we read it is 2 is less than r, or if you looked at it from the r's perspective, the mouth is eating the r, right? You remember when you were a little kid and they talked about greater than less than, the mouth is hungry and it eats the biggest thing like Pac-Man? Okay, so it's a hungry Pac-Man and it's going to eat the r because the r is bigger. So r is bigger than 2. And if r is bigger than 2, then that means from 2 up to infinity, right? Not down to negative infinity, bigger than 2. R is the big one, 2 is little. R is bigger than 2, so from 2 to infinity is how we write our answer, and there was not an or equal to, so we'll leave it like that. Questions on that? All right, number 14. Let's go back to Michael. Third tries the charm.
X is less than 3.
X is less than 3. How could I write that?
Negative infinity, comma 3 with parentheses around it.
Perfect. Negative infinity to 3 with parentheses around it. Number 16. Let's go back to Maddie. Let's reduce that 18 fourths. Divided 2. 9 halves or 9 two-ths, right? And so if it's less than or equal to 9 halves, how would I write that in inequality notation? There we go. Let's go to go to Kendall on number 18.
Y is greater than 3.
Y is greater than 3, so in interval notation.
Parentheses 3 and then comma infinity parentheses.
Good, 3 to infinity in parentheses. And then number 20, back to Genesis.
I had trouble on this.
Had trouble on that one, Abby?
Y is less than negative 1/2.
Y is less than negative a half, or in interval notation.
Parentheses negative infinity, comma negative 1/2 parentheses.
Good, negative infinity, comma negative a half, all in parentheses. Let's take a look at number 20. Once again, Genesis, we see a binomial squared. So once again, what 3 steps?
First square less.
So what do we get when we square the first?
Square
Square the last.
-9.
Oh, remember when you square, you always get a positive. Maybe that's part of the problem, right? Positive 9. And then we have to multiply and double. The negative 3 times 2y and then double it.
12.
Negative 12y. 12, but keep the negative, keep the y. All minus 9 is greater than, it says 2y quantity squared. And then, of course, plus 6. We'll be able to cancel the 4y squares. I can also cancel the positive negative 9, which are right there together because they're inverses. So all I'm left with is negative 12y is greater than 6. We'll divide both sides by the negative 12. And since we divide by a negative class, switch the inequality, make this a less than, and there's our negative half. So since it's smaller than negative a half, negative infinity to negative a half is our answer. Questions on that one there? Questions on that? Going once or questions? All right, anyone perfect on that? Anyone perfect? About 9 out of 10. 9 out of 10 just missed one. All right, 8 out of 10 just missed a couple. All right, so most of us just missed 1 or 2. Any questions on any of them that we need to see worked out? We've worked a few of them. Any others we need? Going once. Going twice. Gone. All right, put the get the equation handout back out. Go back to the equation handout we've been working on for a couple days now. I want you to do numbers 22 to 30 even. So the equation handout, 22 through 30, the even. Go and spend a few minutes working on those 5 problems. And my recommendation would be to do the work on paper rather than trying to squeeze the work into that little space, since these equations are getting a little bit bigger. Or perhaps work them at the bottom of the handout. Right, numbers 22, 24, and 26 are on the chalkboard. If you're finished with all three, check your answers. Now, if you're still working on them, then keep working. But if you're finished with all three, check your answers. Anyone 3 for 3 so far? Maddie, good. Abby, excellent. All right. Any questions on 22, 24, or 26? Joe, for sake of space on the board, could everyone check your answer to 22? How many got r equals 7 for 22? All right. Keep working then. Questions 22. I'm about to erase it so I can put up another problem in its place. Do we see what happened?
Oh, yeah.
Okay. All right. 22 comes down, and I'll put 28 in its place. Oh boy. Check your answers to 24. How many got x equals 2 on number 24? Right here. 2. All right, any questions at all on 24 before I erase that one? All right, continue. Ew. Once you finish, you can check your answers. Looks like Maddie's finished. Maddie's checking her answers. Looks like Abby's done. the top half of this equation page wasn't too bad, but now you get into these and it's Algebra 2. Wouldn't want to insult your intelligence or anything. Insult you in other ways, yes, Brandon, but not your intelligence. All right, for sake of time, go ahead and put your pencils down, even if you're not finished. Let's take a look at 26, 28, and 30. On number 26, there was only a little bit of distribution to do here, though we do want to watch out for the distribution of the negative. And we had a binomial to square here. Square the first, square the last, multiply and double. Otherwise, a lot of combining terms, though I do see the d squares cancel away, which is nice. But to combine all the d's, well, all both of them, to get 2d, combine these numbers together, get negative 83. Over here, nothing combines. 2d's little, brought it over as a negative 2d to get 4d. Sent the 9 over as a negative to get negative 92. Divided both sides by the 40, d equals negative 23. How many have that on 26? 26. All right, questions. If we missed it, do we see what we should have done? All right, we found a mistake. Coming over here, there were 3 binomials in a row. So pretty much pick any 2, foil them. I picked the last 2 to foil, so my first binomial would still be sitting there for double distribution. So I foiled, then I double distributed and ended up with that, okay? And then still had the negative 9n squared. I think there was a 4 to distribute right here, but nothing real complicated there. The n cubes conveniently cancel. The 9n squared and negative 9n squared cancel as you combine them. So the initial steps really here was hard. After that, a lot of stuff cancels. It becomes pretty easy. 20n moves over as a negative to get 8n. 4 moves over as a positive to get 16. And it's 2. And we got 2 for number 28. All right, questions 28. Questions. Does it make sense? 3 binomials in a row, foil 2, then double distribute the second. All right, and then on the last one, this is just big. We had a binomial to square here, and we had a binomial to square here, and we had a number to distribute. Now, I do want to point this out. Order of operations, multiplication or exponent. Which comes first? Exponent. So don't distribute the negative 4 and then square. Rather, square first, then distribute the negative 4. Does that make sense? And then over here, there's just a bunch of parentheses. There's a little distribution to do inside. I went ahead and distributed. Then I went ahead and combined some terms to make this distribution a little quicker. And then here, of course, canceled off a little bit, not much. Combined some stuff. Notice there's a negative 4x on both sides, so I get to cancel some more stuff. The only x left is over here, and that's a negative. So I brought it over as a positive, ditched the 5 as a negative to get 31. And when I got it, I was like, that's kind of a weird answer. Let me check. Yep, 31's correct. How many got 31? Those who made it that far. All right, just Abby. All right, those who, even if you didn't make it that far, how many say, I didn't get there, but as you're kind of explaining it, yeah, it makes sense, just, looks nasty. All right, any questions on this? Any questions? All right, get your inequality handout back out then. Inequality handout back out now. Now I want you to do numbers 3, 7, 11, 15, and 19 on the inequality handout. And the only difference, you multiply or divide, usually divide, by a negative class. If you divide by a negative class, switch the inequality sign around to face the other way. That shows there were no less than or equal to or greater than or equal to in this set. That's weird. Okay. I was wondering if I miscopied something. Several people finished. Let me double check my answers real quick. Yes, the answers on the board are correct. Take another 30 seconds or so to finish, and if you finished already, checking your answers against the board. Pencils down, even if you're not finished. This first one, I think I made harder than I should have. I brought the 4 over as a negative to get 12 is less than negative W. And I was like, well, I started dividing negative. I'm like, I'll just change the signs and then flip the inequality around. I'm like, you know what might have been quicker is if I brought the W over as a positive and ditched the 16 as a negative and just gotten W as less than negative 12. That might have been easier. Either way, negative infinity to negative 12 is our answer. How many got that for the first one? On the next one, again, everything in parentheses right now because there were no or equal to's. Had there been an or equal to bracket, but there weren't any. Here, subtract the 3, divide by 2, negative infinity to 5 halves. How many have that answer? Question. Look at the next one. I didn't want to mess with the negative x again. I had enough issues with it over here, so I'm like, okay, I got this now. I'm going to move the 36x over, and I'll bring the 6 over. So the 6 came as a negative to get 18. Obviously, that just became a positive 36x. Divided the 36 to get a half is less than x, and that means x is the bigger one, meaning all my possible answers are bigger than the half, so half to infinity. How many have that for number 11? Questions on that one? On the next one, had some distribution that I did initially, combined some terms, brought over the negative 5x to get 8x, set the 14 over as negative 12, and it didn't work out great, but it was at least reducible. X is less than negative 3 halves, so negative infinity to negative 3 halves. How many of that for 15? Questions? And then on the last one, had some foiling to do right here, and then had, was it a distribution? Yeah, distribution to do here. The r squares conveniently canceled out. I brought the 9r over as a positive to get 15r, ditched the 22 to get a negative 2. Not a pretty answer. Negative 2 15ths. R is bigger than that, right? So negative 2 15ths up to infinity, our answer. How many got that on number 19? All right, questions on any of these? Questions on basic equations and inequalities? Going once on questions. Going twice on questions. All right, next section in your notes. Solving compound inequalities. Solving compound inequalities. So far, every one of our answers has been an unbounded interval, meaning it has either gone up to infinity or down to negative infinity, because there's really only been one inequality to reference. You'll recall that a bounded interval has 2 points, and the bounded interval falls in between those 2 points. For a compound inequality, then, we're going to have 2 points of division. Look in your textbook, if you would, at page 73. Get your textbooks out and turn to page 73. We're given this basic compound inequality, 20 is less than 10x is less than 30. You'll notice here's the x. Well, if this were an ordinary inequality or equation, I said, how do we get x by itself, class? You'd say, divide by 10 on both sides. Well, now there's three sides, right? There's this side, this side, this side. There's three places. So we're going to divide everything by 10. We're still going to get the x by itself like we always have. It's just that what we do to one thing, we have to do to everything. Does that make sense? Because there's not just two sides now. And we end up getting here, class, is less than 3. And since 2 is less than x is less than 3, we could write this in interval notation, 2 to 3, since there are no or equal to's, in parentheses, and we're done. Pretty easy. Really nothing too challenging, again, except that there's a third place we have to account for. Turn the page. Let's look at the next example. We've got the inequality 12 is less than or equal to negative 4x, positive 4 is less than or equal to 48. I want to get x by itself, but there's two steps to getting the x by itself. First, I've got to get rid of the less attached positive 4. How do I get rid of that positive 4, class? We used to say move it over, right? But there's two places now, so we'll go back to the more conventional thing that we talked about in Algebra 1, where we said put a negative 4 on both sides, or in this case, put a negative 4 everywhere. That's going to cancel the positive 4, so that here I now have, class,
8
is less than or equal to negative 4x is less than or equal to 44. Now, how do I get the x by itself? Divide everything by, divide everything by negative 4. In any inequality, when you divide by negative, class, you have to flip the sign around. Well, here there's two signs, and they're both going to have to flip. This is the only thing that makes compound inequalities hard. I say hard, not too bad. But, here we divide, of course, and we get negative 2. But we're going to flip the inequality and make it a greater than or equal to. Here, of course, we have x by itself. Here we're going to flip it around, get greater than or equal to negative 11. The problem is you cannot leave your answer like this. You cannot leave greater than or equal to, because on the number line, numbers get bigger as they go this way. The signs open almost make it look like the numbers are getting bigger this way. That's not logically sound, right? Here's 0, here's negative 2, here's negative 11 down here. So what we're going to have to do is to flip the entire inequality around, almost as if you're picturing yourself on the other side of this chalkboard and somehow seeing through it, like a glass board. I don't know if you've ever seen those. Glass boards you can write on and you can see through both sides. Well, if you were on a glass board, you'd see the negative 11 first. Then you'd see a less than or equal to x, less than or equal to negative 2. That's what you'd see from this perspective. And that's what we need to make it say. Negative 11, flip this back so the point still aims at the negative 11, mouth open to the x. Make this point to the x, mouth open to the negative 2, so that the order lines up with what you would see on a number line. Does that make sense? That's the only little weird glitch. Otherwise, you're getting x by itself. We've been doing that for years, right? Is get rid of the 4, divide away the negative 4, flip the inequality. I just can't leave it like this. And so we end up with this final answer here. Questions on that? How many remember doing that in Algebra 1? Okay, a couple of you, several of you not, okay. Let's take a look at page 76 now. Page 76. Let's do number 26 together. Write it down on your paper or there in your booklet. 18 is less than or equal to 3x. Negative 3 is less than or equal to 21. What do we need to do first? Brandon?
Add 3 to each side.
Add 3 to everything. Right? Everything gets a plus 3. All 3 places, right? So the my inequality will now say
21 is less than 3x equal to, and less than or equal to 24.
All right, and now what do we need to do, Genesis? Good. And most inequalities are going to really be this easy, right? It's only when you divide by that negative that things get nasty. What's our answer going to be, Genesis?
7
Well, less
or
than.
equal to x, less than or equal to 6.
24 divided by 3. 8, there we go. And of course, calculator if you needed it. You just didn't think you needed it. And you didn't. Now, how will I write this in interval notation, class?
So 7, 8 with brackets.
Good, 7, 8, both of them with brackets around them. And there's our answer. All right? This is a normal inequality, nice and easy, right? Again, it's just if you divide by the negative and you flip the signs, then flip the whole thing in the last step. Several of these for you to work on, unless there's any questions before we're ready to practice. All right, write this one down if you would. Negative 3 is less than x plus 1 is less than 4. Negative 3 is less than x plus 1 is less than 4. I'll have a few more for you to work on to start on that one first. Not that it'll take that long, you know. All right, pencils down even if you're not finished. The first three, pretty straightforward. You take a 1 away from everything. You get this, write it in interval notation. Here, you divide 4 from everything. You get this, you write it in interval notation. Notice the bracket here, but the parenthesis here. On the next one, 2 steps. Start by putting a -1 everywhere, then divide the 2 everywhere to get this, put it in brackets in the interval notation. How many good on the first 3? You're good on the first 3. Coming here now, the first step, of course, take 2 away from everything, then divide everything by -3. So we notice that these signs are going to rotate. When I flip the whole thing around, I'm going to start by writing, class, the -7. But I need to make sure that the point aims at the -7 and the mouth opens to the x. Then this point needs to aim at the x, and the mouth needs to open to the -4. Or, in interval notation, the -7, then the -4, a parenthesis on the -7, a bracket on the -4. Now, I will point this out. We left our answer this way in Algebra 1. Sorry, move this out of the way. We left the answer this way in Algebra 1. You could cheat just a little bit and bypass the intermediate step. Which number comes first on the number line, class? Negative 7. So write that number, then write the other number. Make sure the bracket is with the negative 4. Make sure the parentheses with the negative 7. You can technically skip the rotate step as long as you write the numbers or numerically. So which of these numbers comes first, class?
3.
So write the 3, comma, 6. What do I put on the 3?
Bracket.
The bracket. And on the 6, put a... So there's a little bit, because we're using the easier interval notation, we can save ourselves a little work. And mathematicians love that, because mathematicians are lazy. Homework for this evening is to do page 76. Page 76. The practice, numbers 11 to 25, teal problems. T-E-A-L, the tealy little aqua-y colored things. Okay, page 76, practice 11 to 25 teal, and the review numbers 1 through 6. And the review numbers 1 through 6. Page 76, the practice 11 to 25 teal, and review 1 through 6. Don't forget your exam is on Tuesday in lesson 44. All right, have a wonderful rest of your day, and you are dismissed.